Hello, continuing on with Energy 101, we're on looking at energy sources, and we first looking at fossil fuel sources. We looked at coal first, and today we're looking at natural gas. So natural gas is one of the major sources that we get our energy from to do the things we would like to have in society. This is the pie that we've seen before. Coal is 20. We talked about that. Natural gas 26. So let's talk about where we get that natural gas and what we do with it. This is what we do with it. 34% of it is used in electric power plants, and 21% of it is used in residences for heating and cooking, and 14% in commercial buildings, that's to heat the buildings, and in restaurants for cooking and ovens and things. And industry is 30%. A lot of that is for things like drying. Here in Georgia, we have major carpet industry, and a lot of energy, natural gas is used for drying carpet after it's dyed and processed. So those are the major sectors that our natural gas is used. For automobiles and vehicles, we have a very slight, it's actually, I think, less than 0.1%. It rounds off to about 0.1%. But that's talked about quite a bit today. And if we could get more vehicles converted, that would reduce our oil consumption, which is a much bigger issue than gas, natural gas, as we'll see in later on in the course. But that's where our natural gas goes. As I've mentioned before, coal is a solid, oil is a liquid, but natural gas is the gas, like air. It's gaseous, and not like gasoline, but gas. As a matter of fact, I try to put natural in front of gas when I'm talking about natural gas as a air-like gas, because most of the time refer to gasoline as gas in our everyday vernacular. So in here, though, natural gas and gasoline could get confused if you call both of them gas. So natural gas is the gaseous fuel that comes out of the ground, as we'll see. It has a chemical formula of CH4, and I put it in red here because this gets confused as we move forward. I will use methane and natural gas interchangeably because natural gas is methane because it consists of essentially all of CH4. It's got a few other minor things in it, but they're almost negligible. So when I say methane or natural gas, one is redundant. Either one is what CH4 is. It's odorless, that's a problem. For safety reasons, you can have a major leak. Your stove can be leaking it and fill the home with it, and you wouldn't know it until the spark ignited it and your home would blow up. So for safety reasons, you put an odorant. That's not natural gas you're smelling. That's the odorant that we put in natural gas so that you will smell the gas if you have a leak. And as I noted, it's not gasoline, which is made from oil. The chemical reaction here we looked at for coal, which is carbon, but in this case, since we have CH4, we've got carbon and hydrogen that we burn. The oxygen it takes two oxygens now, two O2s, that is a naturally occurring molecule in the air, and the carbon goes to CO2, and the hydrogen goes to H2O, water. So now notice that we're getting energy from two reactions. One is carbon reacting with oxygen to form CO2, which is our global warming issue, but we also get energy from hydrogen reacting with oxygen, and that forms water, which is not a environmental problem or issue. It's not global warming, it's not a pollutant in any way. This comes off that. Matter of fact, most smokestacks, what you think is smoke coming out of stacks, is just water vapor and not smoke in and of itself. Almost in every case now, the steam-like substance you see coming out of smokestacks is water vapor. And as I mentioned, heat is released, and from both reactions, both the carbon reaction with oxygen and the hydrogen reaction with oxygen. So that's the chemistry of it. You hear a lot about gas production increase now because of horizontal drilling and fracking. What is horizontal drilling? Is when we bore a horizontal well. Once we go down, I got a diagram here to look at that in more detail so we can see it, get a better perspective of it. And what is fracking? Fracking is when we pump a very high pressure mud, it's a water sand kind of mixture, into the drill well that's put in at high pressure, and it fractures the earth around the borehole to increase gas flow out of the shale formations. And here's a diagram that shows what happens here. We drill a well down vertically and then magically turn horizontal. They're like robots. We can steer them and make them go anywhere we want to go. And that gets more exposure to this shale or coal bed methane that we're drilling for the natural gas. But this is a tight formation, and it's not porous at all. So if that's all we did, we would get very little natural gas out of this well. So we pump down high pressure fluid inside the well that we drilled and put it at very high pressure, and it fractures this shale and rock bed down underground and makes it porous. As a matter of fact, there's sand mixes what makes it mud, and chemicals that gets into the crevices that we've cracked and holds it open. And the sand that holds it open is porous, and the natural gas will flow through it. This is the old style well, or the vertical well, where we have to find gas that's in a gas pocket that's in sandstone, and the sandstone is very porous, and the gas will flow out through the sand into the well pipe and go to the top. So that's what we mean by horizontal wells, horizontal drilling, and fracking. Fracking is not anything new. I witnessed an oil well being fracked back in the early 1980s up in West Virginia. But horizontal drilling is fairly new in the last 10 years or so. It started being used quite a bit and became economically viable. And it's a combination of the two that's really made additional natural gas resources available to us. This is what the drilling site looks like. It's got a lot of equipment, but it's all located at the wellhead where we drill it. This is the activity you see when one is being drilled. How do we transport it? We can't transport coal, we said, by train. We transport natural gas, which is a gaseous form, by pipeline. So we build pipelines all over the country, underground, above ground, and pipe it. And it's a much cheaper way to transport a fuel than rail or truck or any other boat or ship or any other way. Pipelines are very low cost, reliable and efficient way to ship fuels. What's our production of natural gas? Here's the long-term history. We just, natural gas started being produced when we started producing oil, actually. And looking for oil, they would find gas, or some gas comes out with oil, and they used to just flare it. In some cases they do now, just to get rid of it because they don't have pipes available to carry it away and to use it and to sell it. So we've seen a growth in the natural gas, that mainly because we've put pipelines in, and now we drill for just natural gas alone, whereas we used to be just a side product of trying to get oil. Notice again, we've hit kind of a high back in the early 70s. That's around 19, and these are TCF per year. That's TCF, that's trillions of cubic feet. Don't worry about those units, but that's what they are. They're cubic feet of natural gas, where the natural gas is at atmospheric temperature and pressure. And that's how many cubic feet it would occupy. And we produce and consume about 20 trillion cubic feet per year. And we produced about 19 back in the early 70s. We dropped down it's vacillated between about 15 and 20 as we see here. And we just in the 2012, I believe, have come up above 20, forgotten the exact number, but it's 20 point something or 21, somewhere in there. But this is a recent growth in our natural gas production in the short term due to primarily horizontal drilling and fracking. So let's look at the big picture, because these are just that's just natural gas production right here, not consumption production. Well, we do import a little bit of natural gas, whereas coal we actually export about 8%. Here we actually import some natural gas, and the dark blue are the imports. So this is imports here. Notice imports right here, down in this dark blue, and what's above it is stacked on top of it, and that's what we produce. So this is our consumption. Notice this is a chart of consumption versus production. Make sure we start noticing those. They'll make a big difference. Obviously, whether we're consuming more than we're producing or producing more than we're consuming. And natural gas is a pretty good balance. We're importing some. But where are we importing it? Well, as you noted, you have to, right now, the best way to transport natural gas is by pipeline, and that means it's easy to import it from Canada and Mexico, where we can build pipelines, and that's what we do, and that's where essentially 98% of our imported natural gas comes from Mexico and Canada. So that's what this represents down here. It comes from North America, so you can say that we're independent and energy free in natural gas regarding North America, not the U.S., but North America. We're pretty energy independent when it comes to natural gas. So we import 14% of natural gas consumption. 90% of these imports come from Canada, so about 12% of our total natural gas that's used comes from Canada, and about 2% comes from Mexico, and then the remaining 2%, you notice there's still about, that only makes up about 98%. Where do we get the other 2%? It comes from liquefied natural gas, where we liquefy it, but that's a very expensive process. You have to refrigerate it to minus 250, 260 degrees Fahrenheit or so. So it requires an expensive cooling process and special things to ship it in. But we do import some LNG, liquefied natural gas, which is not easy. So back to our energy sources, we won't go over that again, but we just talked about natural gas, we've talked about coal, and next time we'll talk about oil, which you notice is the big dog regarding where we get most of our energy from in this country. And I believe that concludes it, and thank you. See you next time.